So in the last class, we done with what are the, how to measure the atmospheric pressure plus absolute pressure, different types of densities. These topics we done kada. Today, how to measure the atmospheric pressure with an instrument. Let's see, that is called a barometer. Barometer. So barometer is a unit. Barometer is an instrument. With that, we can measure the atmospheric pressure. Now, let's see that. Let's construct the barometer. The barometer has a tumbler, glass tumbler. So it is a glass tumbler. It is empty tumbler, and it has a long 1 meter. 1 meter tube. 1 meter test tube here. In this test tube, we have a mercury, totally completely filled with this test tube completely filled with what? Mercury. Completely filled with what? Mercury. This is a mercury. completely filled with mercury. Now, this mercury 1 meter test tube mercury column will place that in this container. Where you place this mercury? Because here it is, one side is closed, another side is open. This, okay. Now this is, you will keep inverted. When you keep inverted, what going to be happen? Tell me what going to be happen? Some of the mercury will what going to happen? Some of the mercury will come into the column, and some would be stay in the test tube. Yes or no? So some amount of the mercury will come out, some amount of the mercury will stay. Now here, observe that. Let us observe that this is a one point, this is other point, this is other point. How many points are there? 3 points you should observe here. These 3 points are in the same horizontal level. These 3 points are same horizontal level. But observe that across this, let us assume that this point is A, this point is B, this point is C. Across point A, you will have the pressure because of the atmospheric. Across C also you have the pressure due to atmosphere. But across the B, you will have what? Because of this mercury column. Because of this mercury column height, because of this mercury column, you will have pressure at here. But pressure at A and pressure at B and pressure at C all are equal. Why this pressure at A, pressure at B, pressure at C, the pressures are equal? Because they are at same horizontal level. In a same horizontal level, pressure is equal. Pressure does not depend upon the shape of the container. Pressure only depends upon the liquid column height. Okay? So here, pressure at A, pressure at B, pressure at C, at all the positions, pressures are equal. But pressure at A is having because of the atmospheric pressure. Pressure at C also because of atmospheric pressure. Pressure at B you have due to this liquid column height. But pressure due to liquid column formula is H rho G. Here H is the height of the liquid column. Generally, for normal atmospheric pressure, the mercury column will raise as 76 centimeter. Since here height would be 0.76 meters and density of the mercury is 13600, acceleration due to gravity is 9.8. So finally, all the things you can find, multiply all the things. How much is the answer we have calculated? 0.76 into 13600 into 9.8. So totally how much? 101.10129.2.8. This is the value. So this you can write as 1, 2, 3, 4, 5. So 1.012 into 10 power 5 Pascal. So this is your atmospheric pressure. It is actually approximately 10 power 5 Pascals. Approximately how much? Approximately the value, this value is approximately 10 power 5 Pascal. This 10 power 5 Pascals also known as a, this atmospheric value also known as a 1 bar. So here 1 bar is equal to 10 power 5 Pascal. So even 1 atma is equal to 10 power 5 Pascal. So this is the atmospheric pressure. 1 atma is a unit for pressure. Even bar for the units for pressure. So 1 bar is equal to how many pascals? 10 power 5 pascals. Even 1 atma is equal to 10 power 5 pascals. This is approximate values. So this is how you can find the pressure, atmospheric pressure by using the barometer. So here in this barometer, this gap is known as a Torricelli leak gap, and due to this liquid column height is showing the pressure of the atmospheric. For example, if this liquid column suddenly falls down, it is indicating that indicating that cyclone. It is the indication of the cyclone. It is indication of to get the cyclone in the region. So this is how the atmospheric and a barometer will be useful for identifying these situations. And this is known as a barometer. Okay. In the barometer, what things will be present? Container is present, a lamp tube is present, and mercury is present. Now here my question is, instead of mercury, can you use the water? Yeah, you can use water, but this liquid column must be greater value. So that is the reason we are not using any other liquid than mercury, because mercury has a high density. Because of that reason, it takes only less length of the column to give the same pressure. Instead of that, mercury, if you use another material, it would have more length of the liquid column, or this test to be required. So that is very tough to handle this barometer. So that we are not using other material. We are using only mercury. So this is all about barometer. Take note. Note down. Done. Next, let's go for Pascal's law. Next one is Pascal's law. So what is this? Let us write the Pascal's law. In a liquid, in a closed container, or in a liquid, in a closed liquid, in a closed liquid, pressure is transmitted. Pressure is transmitted equally in all directions. In a closed liquid, pressure is transmitted equally in all directions. This is a statement of what? Pascal's law. So in a closed liquid, in a closed static liquid, pressure is transmitted equally in all directions. Now here, then how can you explain this thing? We can explain this thing by using some structures. So let us assume that these are a closed container here. This is this is a closed container. This closed container, I am arranging 4 pistons. I am arranging 4 pistons. This is one piston. This is other piston. This is other piston, and this is one more piston. This is the way. How many pistons are there? 4 pistons are there, and this is completely filled with incompressible liquid. So example for incompressible liquid is hydraulic oil. Hydraulic oil is a incompressible liquid. Totally it is a filled with what? Incompressible liquid. Totally it is filled with what? Incompressible liquid. And here area of cross section of this piston is A1. Area of cross section of this piston is A2. Area of cross section of this piston is A3. And area of cross section of this piston is A4. This is a very different area of cross section the pistons have. Now look at here. I am applying a force. Here I am applying a force F1. When I am applying the force F1 across this piston, this force is acting on this A1 area. So what going to be happen? Some pressure is exerted. How much is the pressure exerted here? By using the formula from the pressure, find out. Tell me. Pressure exerted here P1 is equal to F1 by A1. But whatever the pressure exerted here, because of this totally closed liquid, whatever the pressure is exerted is going to this piston, even for this piston. Understand? Whatever the pressure exerted here, it is reaching to this piston, and even this piston. At a time, simultaneously happened this. Yes or no? When it happens simultaneously, here something pressure across the second piston, something pressure is exerted. That pressure you can take P2. That P2 I can write as F2 by A2 by using the pressure formula. Similar way across A3 also you will have some pressure, that is you can take pressure 3. You can write F3 by A3 by using the pressure relation. Here also across the piston 4, pressure is exerted F4 by A4 you can write. But here pressure exerted at all pistons is equal, because according to Pascal's law, what is telling the Pascal's law? Pressure exerted in a liquid transmitted in all direction equal. So whatever the pressure exerted here, because the first piston, this liquid is transmitting the same pressure here, and here, because of the complete, it is totally filled with a incompressible liquid. That incompressible liquid is passing the same pressure to all the pistons, which means that P1 is equal to P2 is equal to P3 is equal to P4. So by using this I can write as P1 means F1 by A1 is equal to F2 by A2 is equal to F3 by A3 is equal to F4 by A4. So this is showing that Pascal's law equation. Understand? Means pressure is transmitted equally in all directions. So that is telling that Pascal's law. Here, what is this Pascal's law uses? This Pascal's law is applicable in hydraulic machine. You know pulsar bikes? For pulsar bike, it has a disc brakes, isn't it? The disc brakes also is working on this Pascal's law principle. Even hydraulic brakes also, that is actually called hydraulic brake. The hydraulic brakes for the cars, hydraulic machines, hydraulic press, everything is working on the principle of the Pascal's law. So here what the Pascal's law is telling, the Pascal's law is making the force multiplier. Here only you have one force, but because of this liquid, you are having how many forces? You have 3 different forces. Because of this, you are using one single force, but we are getting three forces, which means that here the Pascal's law is utilizing as a force multiplier. Understand? Now, how this Pascal's law is useful in the case of the hydraulic machine? Let us see by using the structure of the hydraulic machine, construction of the hydraulic machine. So, in the hydraulic machine, first write down hydraulic machine. Hydraulic machine, even hydraulic brakes also are working the same principle. The hydraulic machine has two different cross-sectional area plungers. This is first piston, this is first piston, and this is second piston, and it is completely filled with incompressible liquid. This totally filled with incompressible liquid. Now here area is A1, here area is A2. Now here you are keeping the loads. You will keep the loads. Okay, here you will keep the loads. Now here load is applying some force. Let us take this is F1, F2, and here you are applying some F1 force. When I am applying the F1 force across this small plunger, so this will press this force is pressed on piston on A2, A1 cross section area. Because of this force acting on area A1, so something pressure is exerted. The pressure you can take it as a P1. The P1 is equal to F1 by A1. That pressure is transmitting through this an incompressible liquid to reach into the other side. When it reaching to the other side, so what going to happen here also something pressure is exerted. The pressure is you can take P2, but whatever the pressure exerted here, same pressure is reaching to this position, which means that P1 is equal to P2. Understand? Whatever the pressure exerted at here, same pressure is reaching to the other machine, other side, so that P1 is equal to P2. But here you know P1 means F1 by A1, P2 means F2 by A2. So this formula is telling you, this formula is useful for lifting the hydraulic machine, lifting the objects which we are keeping the loads. So on the small piston you apply small force, but here outside you get a large force. So this large force is applying the loads, lifting the loads easily by using this by using this hydraulic machine. Even hydraulic brakes also working on this same principle. Okay, this is your hydraulic machine. Understand? Tell me. Not equal. They are different. A1 is here. A1 is less than A2. Which side you are keeping the loads? That area having the more area. Here this liquid is incompressible liquid. Example is what? Hydraulic oil. Generally in the market the hydraulic oil will be available. It has a different density. So and it is having a capability of receiving the heat energy. Okay, even though much heat is delivering to the hydraulic oil, but the temperature will not increase more than 40 degrees centigrade. Such kind of oil is known as a hydraulic oil, and it is a incompressible liquid. That is the reason we are using here. Instead of this hydraulic oil, if you use any other liquid, the other liquids may incompressible, so we cannot use that other liquids. Got it? So this is what today's topic: hydraulic oil and Pascal's law and barometer. So these two topics we done today. So this is barometer and this is hydraulic machine. Okay, na? So anyhow today I'll stop the session. In the next class, we'll continue Archimedes principle, buoyant forces, and force for my formula for buoyant forces. These all things we'll discuss in the next classes. Okay, na? Amma? Yeah, sure. Yeah. Shall I stop the session? Yeah, I'm ending the session. Bye.